Hello. Today we're going to be discussing a small hotel booking database that was designed by me, Andrew Hitchcock, and my partner, Christian Baker. Our database has a few requirements. For starters, we need something that can track rooms and information about those rooms, such as cleaning status and staff assigned to clean those rooms. Additionally, we need to track our guests. We need to track information about them and bills relating to these guests. Finally, we need to track bookings, which hold everything together. Those bookings include information about rooms, dates, guests, and staff that made those reservations. Here you see an example reservation. Something like this would be received by us and entered into our database, and then distributed among our employees so that they would have the resources they need to make sure that the guest is taken care of and the hotel operates at peak performance. The layout of our database is fairly simple. We have 6 tables. We have a booking table, a front desk staff table, a housekeeping staff table, a rooms table and a guest table, and finally a folio table. As you can see, the booking table acts as a hub, joining most of the rest of these tables. We see guest tables that are linked to the folio table and the booking table. We see rows in housekeeping staff that are mapped to rows in the rooms they are assigned to clean, so we can keep track of who has what rooms. And then we see information in the front desk staff table mapped to the booking table, so we can keep track of which employee made which booking record. On the business side of this database, our rooms are our primary asset. We need to know some information about these rooms. Since our rooms are our primary asset, we need to know if they're clean or if they're dirty. We need to know if a room is reserved or if it's available. And we need to know what housekeeping staff is assigned to clean which room. From the business side of things, guests are our primary income source. We need to know several pieces of information about our guests so we can properly take care of them. We need to know how to contact our guests so we can let them know when their rooms are available. We need to know how we can send mail to our guests so we can send them a postcard and invite them to stay with us again. We need to know how much money our guests owe us. After all, this is a business. And we need to know when our guests are staying with us and what room they're staying in. That way we don't have any double bookings or any problematic situations that arise. Bookings are a great way to keep track of everyone's coming and going. With our bookings table, with our booking procedure, we'll know who will be staying with us, when they are supposed to arrive, when they are scheduled to leave. We'll know where they're staying in our hotel. We'll know how much it will cost them so we can tell them beforehand. And we'll know which staff member helped them make the booking so we can respond effectively if a problem does arise. To implement our database, there are a few things we need to consider. As mentioned before, we have 6 tables residing within our database. Those tables are, in no particular order, our booking table, our front desk staff table, our housekeeping staff table, our guests table, a table for our rooms, and a table for our folios. These tables are going to be relating to each other, so we do have to design and create our tables in a certain order in our database management system, or else we'll run into problems. We'll go through the implementation of these tables in our DBMS in the order that we implemented them. For starters, we implemented both of our staff tables first. Since these tables don't have any foreign keys, they can be created without any problems. Our 2 staff tables are our housekeeping staff table and our front desk staff table. Inside of our housekeeping staff table, we record information such as a staff ID, the name of the individual staff member, and a salary for each houseworking employee. Very similar, our front desk staff table also records an ID number for each staff member, the name and the salary number for each front desk staff member as well. You can see a picture below from the front desk staff table. The reason we kept these in 2 separate tables is because although they are both staff members, they serve very different roles, and in the future, if we were to expand this database, we might want to add more columns to one or the other. And implementing them this way, separate, we're not going to run into as many problems. Next, we come to the guest and the folio tables. Specifically, the guest table was created next, since it also does not have any foreign keys. In this table, we record several information about our guests. Specifically, we assign a unique identifier for each guest. Now, this is independent of their social security number, so if we do have a data breach, we are not going to expose our clients. We also record a guest name, a unique identifier for a reservation number, a phone number, and an email address for each guest so we can be in contact with them if we need to. Next, we implemented the folio table. Inside the folio table, we record a unique identifier for each folio account. We record the guest ID that's associated with this particular folio. Now, this is a foreign key which points back to the guest table. That's why this table needed to be created after the guest table. And finally, inside this table, we record the balance that's owed on each particular folio. Next, in our implementation, we record information about the rooms and our bookings. The rooms table was created next. Inside the rooms table, we record information about each room. We record a unique identifier for each room. In this case, it's the room number itself. We record information about which type of room it is, whether it's a king or a queen or a handicapped room. We have a checksum to see if it's clean or not. We have an identifier pointing to the housekeeper that's assigned to this particular room. And we also have the price, the base rate for each room before any discounts are applied. Finally, you see we have the booking table. Now, as I mentioned, this is the central hub in our database, so this table is big. This table keeps record of a lot of information, such as a unique identifier for the booking itself, a pointer to the folio ID, a pointer to the guest ID, a pointer to the room ID, a pointer to the front desk staff member who recorded this booking, and some information about when the booking took place and the dates for the booking. In our implementation, we also prepared for disaster. We prepared a backup plan for this database in case we ever need to restore any of our tables from accidental deletion or something worse. Here you can see a sample of the code that we used to back up our database. Here we started a spool, particularly for the folio table. We created a file called foliobackup.txt, and you see it's a simple query that's using a substring to record every column in the folio table delineated by commas. We specify which table that we are recording out of, and then we turn our spool off so that everything is nice and neat. Now this is going to need to be parsed, this file that's created. We trust that that can be handled separately. And once the information is parsed into a exclusively comma-separated file, then you can go ahead and restore that database, restore each individual table from that if you need to. In our database, rather than having one restoration script, we created a separate file for controlling each table. Now, we did this by design so that if something did happen to a specific table, that specific table could be restored rather than trying to restore the entire database itself. This will save time and this will save confusion, we believe. After we created each control file, you can use a simple SQL loader to load the data back into the appropriate table. Here you see an example of a control file in the code that works that. You see that first we have to load the data and we give it an in file, and this is the parsed booking table that was parsed out into an exclusively comma-separated file. We tell it to append into a specific table. Here, this is the booking table. And we let it know that the fields are delineated by commas. To run SQL Loader is easy. All you have to do is enter the command SQL Loader control and then give it the control file that you created for that specific table. To conclude, this database is scalable enough to work for a small hotel, and we believe it's also scalable to work with a large hotel as well. Implementing databases such as this one is crucial for hotels of any size, because a database like this helps to record who belongs in what room when, helps us know whether the rooms have been suitably cleaned and are available for new guests, and it helps us control and keep track of who has outstanding room fees, and many more related pieces of information. If anyone has any questions, feel free to contact either me or Christian. Thank you so much for listening to us. We hope you have a good day.